In part 1, we took a look at a few sequences, each of which lasted for W frames. Let's continue our catalog of useful sequences, starting with a random sequence. Here I've created a little random array. It has W entries. Each one is between 0 and 1. So all I need to do is to pull out entries from 0 to W and then go back to 0. That's easily done with the mod operator. So if pattern is my array of floats, then the index I want is the integer value. Remember that open paren int close paren says whatever follows me should be interpreted as an integer. Throw away any floating point. So we take t mod w, which gives us back a number between 0 and w, and then we take the integer value of that, and that's the index into the pattern. I know I'm going through this fairly quickly, but these are meant just to be little recipes. If you want to start fooling around with these and exploring them, by all means, go for it. Let's take a look at the triangle next. The triangle pattern just goes from 1 down to 0, back up to 1, nice and smoothly. As before, it has a width of w. So to create this, I'm going to break it up into 2 lines. First, I'm going to create a little temporary variable called a. The variable a is a float, and it has the value t mod 2 over w. We've seen this before. It means that a now has a value that runs from 0 to 1 as the time steps over w frames. I'm saving this in the variable a because I want to use this value a few times in the next line, and I don't want to keep typing and recomputing it over and over. The next line tells me the value of v. I use another conditional, like we saw before. What this line says, reading left to right, if a is less than a half, then return the value a. Otherwise, return 1 minus a. If you draw a little picture on scratch paper and you test out a couple of values of a, you'll see that this little recipe does just what we want. When a is less than a half, we just have a itself, and when a is greater than a half, we want 1 minus a. Finally, we're going to smooth out the triangle wave. We're going to use the sine wave. Here's the easiest way of dealing with this. Don't even worry about w. Instead, use this little recipe. V equals the sine of something times t. Now there's some empty space there, we'll get there in a second, but let's just focus on what's up on the screen now. SIN is the name of the built-in math routine that computes the value of sine. Now when you write out the word sine and it has a silent E at the end, this is one of those computer things we drop the silent E. So SIN is pronounced sine. And I'm multiplying t by some number. The bigger that number, the faster the sine wave will wiggle, and the faster the values of v will go between 0 and 1, and the faster my animation will go. I start with this kind of thing all the time, and then I change the value of 0.1 until the animation looks right. Sometimes I end up with tiny numbers like 0.000001, and sometimes I have huge numbers like 10 million. But I start here, and then I just play with it until it looks right. One interesting quirk of the sine wave is if you look at the graph at the top, it returns values between -1 and 1, not between 0 and 1. And all of the others are between 0 and 1. So to get the result of this between the range 0 and 1, the easiest way is just call map. Map takes the output of the sine wave and converts the range -1 to 1 to the range 0 to 1. So this is the recipe for using the sine wave. Now, sometimes you really do care about the width w of this wave because maybe you're using it along with other waves. So I'll show you the recipe for using that. If you want to make sure that the sine wave goes from 0 to 1 down to -1 back to 0 in w seconds, then here's the recipe for that. You're going to compute the sine of 2 pi times t over w. Now, I won't go into the mechanics here, but notice that I've written 2 pi in red. It's capital TWO underscore pi. It's a built-in system variable. It's just a number. It has a value of about 6.28. And so if you wanted, you could just type 6.28 in there instead. But it's generally a good idea to use the system variable 2 pi. First of all, it has more digits, so it's a little bit more accurate. And if you get into the math, this will mean more to you as a reader of the code than 6.28. So if you type this in, you'll get a sine wave that has a cycle of w seconds. And of course, just like before, it'll come out between -1 and 1, so we can use map to convert that to the range 0 to 1. So here are the 5 patterns that we've seen in summary. For width of w, we have these 5 little recipes. Now I know we've done this quickly and we haven't gone into the details here, and that's why I've been referring to these as recipes rather than in-depth analyses. Like I said in the last video, there are an infinite number of these things, and there are even just hundreds of basic building blocks, of which these are only 5. But these give you a place to start. So if you have a desired motion or color change or size change or something that you want to change over time in mind, pick one of these that comes the closest to what you would ultimately like to see, and then start tinkering with it. And over time, you'll be able to hone the motion into just the sort of thing you're looking for.